Hey, what is going on, guys? My name is Dev, and today we're going to be going through this HackerRank problem. In this problem, we're going to be inserting a new node at the tail of a linked list. So in the sample function called insert@tail, they pass a head of a linked list, and int data, which we'll have to populate inside of a new node, and insert that node at the tail of the linked list. Now, if you read the above summary here, this above piece of information, the last line here is actually a great hint for anybody trying to do this problem. Basically, it's saying that we need to have a null check of the head, and if the head is null, we're just going to be returning the head as a new node that contains data inside of it. So that's actually a really good point here, because if we don't have the null check, it's going to fail some use cases. So it's always good to read the beginning section of every single problem, no matter if you're doing it in an interview or an online coding challenge or just on HackerRank or LeetCode. So it's a pretty simple linked list problem. It's actually easy difficulty. So if you know how basic linked lists work, this is the constructor of this specific linked list. We pass through int node data, and it sets data for the node, and then it basically says this.next is equal to null. And they also give us the class singly linked list just to see what it looks like as well. So we'll get started here. We'll first have our null check in the beginning. So we'll say that if head is equals to null, then what we'll be doing is we're just going to say head is equal to new singly linked list node containing data, and we're just going to be returning head. Now else, if head is not null, what we'll be doing is we'll create a new node, singly linked list node, and we'll call this node, and we'll set this equal to head. So now what we'll do is that we'll create our while loop. So while node.next is not equal to null. So this is all that it's saying, is that while the next node is not null, which means that we're not at the end of the linked list, then we're going to move node equal to node.next. So all this while loop is doing is it's just basically just continuously making node into the next node until it gets to the last node before it hits null. So after we get out of the while loop, all we're going to be saying is node.next is equal to new singly linked list node containing data. Now I'll actually go through this a little slowly. So let's say I have a linked list 1, 2, 3, 4, and we want to insert 5. So for example, in the use case where head is not null, we get past 1 as the head, and we get past 5 as data. So we're saying that node is now going to be equal to head, so node is 1. Now while node.next is not equal to null, oops, I forgot to add this at the end. So at the end of 4 is going to be null. So now we're saying that while node.next is not equal to null, which 2 is not null, setting node to the next of node. So this is basically going through, it's going to set 1 to 2, 2 to 3, 3 to 4, and then at the last check, it's going to say while node.next is not equal to null, well, 4.next is null. So now it's going to step out of that for loop, or that while loop, sorry. And then it's going to say node.next, so 4.next, is going to be equal to a new singly linked list node containing data, which is 5. And now we're going to be removing null, setting this to 5. And then 5.next is naturally null. Now we'll just return the head of the linked list, which will now contain the new node inserted at the tail of the linked list. Now if I run the code, it should pass all use cases. Now it passed all sample use cases. Now we'll just submit it to run it against all the other use cases here. So great, it passed all the use cases and it looks good. So I hope you enjoyed this linked list problem, and I'll see you in the next video.